Hi, and welcome to Dr. V's Chemistry webcast. In this webcast, we're going to learn how to convert between moles of a substance and mass. We're going to do this by using molar masses. Molar masses are a ratio between grams of the substance and moles of that substance, and we're going to use them to do dimensional analysis problems. You're going to want to get your periodic table and your calculator. I think we should take a moment and review the idea of molar mass before we go on. It's the mass of 1 mole of a substance reported in grams, the grams per mole. It's per 1 mole, and that's going to be important when we get into our stoichiometry unit. The reason we're talking about this is that it's a conversion factor from grams to moles, or from moles to grams, and we're going to use them to solve our dimensional analysis problems. This whole unit is all about dimensional analysis. When students are first learning how to solve these problems, they often find a visual approach to be helpful in terms of setting the problems up. If I want to calculate moles when I'm given grams, so I'm starting with grams, that's what's given to me, and I need to get to moles, what I'm going to do is multiply times 1 over the molar mass. I'm going to flip that molar mass ratio. That's going to end up converting me from grams to moles, which is what I want the problem to do. That brings us directly to practice problem number 1. How many moles are present in a 19.45 gram sample of carbon? Now, carbon's an element, and so we can find its molar mass directly from the periodic table, 12.01 grams per mole of carbon. I want to know moles. I'm given grams. I need to take that ratio and flip it upside down. When I do that, now the unit grams of carbons cancels. So 19.45 divided by 12.01, that's the math I need to do. And that gives me an answer of 1.619 moles. Remember to report your answer with sig figs and appropriate units. I had 4 sig figs in my initial mass of carbon. I'm going to report it with 4 sig figs, and my units are moles. Let's do another practice problem. Now, you might want to consider trying it on your own and then checking your answer against mine. How many moles are present in a 5.99 gram sample of strontium carbonate? And we're given the formula of that. Now, strontium carbonate's a compound, so we have to calculate its molar mass. We've got 1 strontium, 1 carbon, 3 oxygen. So I need to add up the masses from the periodic table, and I get a molar mass of 147.63 grams per each mole of strontium carbonate. I'm solving for moles. I'm given mass. X, what I'm solving for, equals what I'm given. I need to multiply times 1 over that molar mass, because now the units grams of strontium carbonate cancel out, leaving me with moles, which is what I want. And I get an answer of 0.0406 moles. Again, report your answer with the correct number of sig figs. There should be 3 in this problem, and units. Since there are 3 sig figs in 5.99 grams, I'm going to report my answer with 3 sig figs. In both of those practice problems, we were given grams, we were solving for moles. What if we need to go in the other direction? What if we're given moles and we need to find the mass? For that, I'm going to multiply by the molar mass. It's the grams per mole, and that will make my units cancel out. So the mole road is a really useful strategy, especially if you don't feel 100% confident in dimensional analysis. The units really tell you what to do. So of course we're going to do a practice problem. What is the mass in grams of a 3.42 mole sample of aluminum? Now, aluminum's an element. We can find its molar mass right from the periodic table. It's 26.98 grams per mole of aluminum. I'm solving for grams. I'm given moles. If I multiply the moles of aluminum by the molar mass, that means the units, moles of aluminum, cancel out, and I'm left with grams. And I get an answer of 86.3 grams. Now, does this make sense? I have more than a mole of aluminum, so I should have an answer that's bigger than 26.98 grams. Those kinds of checks on your answers, making sure that what you're reporting is reasonable, is a good thing to do. It's a good strategy when you're solving these kinds of problems. Let's do one more practice problem. What is the mass in grams of a 0.22 mole sample of benzene, which has the formula C6H6? Now, this is a compound. We need to find the molar mass of benzene. I've got 6 carbons at 12.01 each. I've got 6 hydrogens at 1.008. When I add that all up, I get a molar mass of 78.11 grams per mole for benzene. Now, I'm solving for mass. I'm given moles. X grams equals 0.22 moles of benzene. And I need to multiply by the molar mass. I've got it set up so that the unit moles of C6H6 cancels. I'm left with an answer that will be in grams for my units. And I've got less than a mole, so I'm expecting an answer that's quite a bit less than 78.11. I get an answer of 17 grams. Yeah, that makes sense. If you found this helpful, let me know. Subscribe to my channel, like the video, leave a comment. Practice chemistry every day. That's how you get better.